Hello, this is our video from the Unit 2, Task 1, Motion of a Particle. My team is by two people, and we are Carlos Leonel Barrera Gamboa and I, Uriel Arismendi Montoya.
Uniform rectilinear motion horizontal. Uniform rectilinear motion is a type of linear motion in which a rigid body moves at constant speed, and its path is a straight line. According to Newton's first law, a body with not net force acting on it will either remain at rest or continue to move with uniform rectilinear motion. Speed and velocity. Speed is the magnitude of velocity vector with constant in uniform rectilinear motion. Velocity is the rate of change of position with respect to time, which has both magnitude and direction. In uniform rectilinear motion, the direction of the velocity vector is also constant, and it is parallel to the straight line path of the body. Motion and displacement, the average speed, point speed. Motion is the change of position of a body over time. Displacement is the change of position of a body from its initial position to its final position. It is a vector quantity that has both magnitude and direction. In uniform rectilinear motion, the displacement vector is parallel to the vector velocity vector and proportional to the time elapsed. Average speed is the ratio of the total distance traveled body to the total time taken. It is all a scalar quantity that has only magnitude. In uniform rectilinear motion, the average speed is equal to the constant speed of the body. Point speed is the instantaneous speed of a body at a given point on its path. It is also a scalar quantity that has only magnitude. In rectilinear motion, the point speed is equal to the constant speed of the body at any point of its path. Main features. The main features of uniform rectilinear motion are: the acceleration vector is zero, which means there is no change in the velocity vector over time. The initial velocity vector is equal to the final velocity vector, which means that there is no change in the speed or the direction of the body over time. The position vector changes linearly with time, which means that the body covers equal distance in equal intervals of time. The trajectory is a straight line, which means that there is no change in direction of the position vector over time. Math expressions. The math expressions for uniform rectilinear motion are: position x equals x0 plus b by t. Velocity b equals v0 equal constant. Acceleration a equals 0. And then some more examples of exercise with uniform rectilinear motion. A runner covers 100 meters in 10 seconds with constant speed. What is his speed and displacement? A plane flies horizontally with constant speed of 1800 kilometers by per hour for 2 hours. How far does it travel and what is its average speed? A car moves along a straight road in a constant speed of 70 kilometers per hour. It passes traffic light at 8 o'clock. What is its position at endpoint speed at 8:15 a.m.? Assuming that the traffic light is at the origin of the coordinated system. Uniformly accelerated motion. Uniform accelerated motion is the motion of an object undergoing constant acceleration that does not change with height. The acceleration can be positive or negative, depending on the direction of the change in velocity. For example, a ball rolling down a slope, a skydiver falling under gravity, or a car drowning are examples of the uniformly accelerated motion. Initial velocity. Initial velocity is the velocity of the object and the beginning of the motion or at time zero. It is a vector quantity that has both magnitude and direction. In uniformly accelerated motion, the initial velocity can be positive, negative, or zero, depending on the direction of the motion and the reference frame. Final velocity is the velocity of the object at the end of the motion, or at a given time. It is also a vector quantity that has both magnitude and direction. In uniformly accelerated motion, the final velocity can be calculated from the initial velocity, the acceleration, and the time elapsed using the formula v equals v0 plus a by t. Average velocity is a vector quantity. Average velocity is defined as the change of in position or displacement divided by the time intervals in which the displacement occurs. The average velocity can be positive or negative depending upon the sign of the displacement. The SI unit is of average velocity is per second. Characteristics. Projectile motion is one of the most popular examples of motion in a plane with a uniform acceleration. In the case of projectile motion, the only acceleration acting on the particle is the acceleration due to gravity. In horizontal direction, the velocity in x direction will be constant since there is no acceleration. Therefore, we can apply the equations of motion separately in two directions to get results. In general, a uniformly accelerated motion is the one in which the acceleration of the particle through of the motion is uniform. It can be moved in one dimension, two dimensions, or three dimensions. When we are talking about motion, it's a straight line with constant acceleration. There are three equations of motion which are helpful in determining one of the unknown parameters, where v equals final velocity of the particle, u, initial velocity of the particle, s, displacement of the particle, a, acceleration of the particle, and t, time interval in which the particle is in consideration. Example exercise. Positive acceleration. A rocket is launched vertically upward with an initial speed of 15 meters per second. It has a constant acceleration uniformly accelerated motion, vertical. The vertical shot. A vertical shot is a type of motion in which an object is projected vertically upward or downward with an initial velocity. The object experiences are constant acceleration due to gravity, which is negative if the object is moving upward and positive if the object is moving downward. Initial velocity is the velocity of the object at the moment of projection. It is a vector quantity that has both magnitude and direction. In a vertical shot, the initial velocity can be positive, negative, or zero, depending on the direction of the projection at the reference frame. Final velocity is the velocity of the object at a given height or time. It is also a vector quantity that has both magnitude and direction. In a vertical shot, velocity can be calculated from the initial velocity, the acceleration due to gravity, and the height or time elapsed using the formulas v equals v0 minus gravity per time, or v2 equals v2 minus 2 gravity per height. Influence of gravity. Gravity is the force that causes all objects near the Earth's surface to accelerate downward at a constant rate of 9.8 meters per second. Gravity affects the vertical motion of an object by changing its velocity and direction over time. Gravity causes an object projected upward to slow down until it reaches its maximum height, where its velocity becomes zero. Then, gravity causes the object to fall down with increasing speed until it reaches its initial height, where its velocity becomes equal to its initial velocity, but with opposite direction. Characteristics. The characteristics of a vertical shot are: the acceleration vector is a constant and equal to minus 9.8 meters per second if the object is moving upward, and positive 9.8 meters per second if the object is moving downward. The velocity vector changes linearly with time, which means that it decreases or increases by 9.8 meters per second in each second. The position vector changes quadratically with time, which means that it follows a parabolic path in two dimensions or a straight line in one dimension. The maximum height of reached when the velocity becomes zero, which occurs at t equals v0 between g, or h equals v2 between 2g. The time of flight is the total time that the object stays in the air, which is twice the time to reach the maximum height, or t equals 2 v0 initial between g minus between g. The range of the distance covered by the object during its flight, which depends on its horizontal component of velocity, if any. Mathematical expressions. The mathematical expressions for vertical shot are: position g equals g initial plus v initial per t minus 1 between 2g per t. Velocity v equals v0 minus g per t, or v2 minus v2 minus 2g per 8. Acceleration a equals minus g. 3 example exercises. A ball is thrown vertically upward with an initial speed of 15 meters per second from the ground. What is its height and speed? A coin is dropped from the tower that is 18 meters height. How long does it take to reach the ground, and what is its speed just before hitting the ground? A rocket is launched vertically upward with an initial speed of 100 meters per second from the height 50 meters. It has a constant acceleration of minus 20 meters per second due to air resistance and gravity. What is its maximum height and time to flight?
Freefall. Definition. Freefall refers to the motion of an object that is solely influenced by gravity, without any other forces acting upon it. In freefall, an object is subject only to the force of gravity, causing it to accelerate downward. Initial velocity. In freefall, the initial velocity of an object is typically assumed to be zero. This means that the object starts in motion from rest, and its velocity increases as it falls. Final speed. The final speed is free fall depends on the distance the object has fallen to the time it takes to fall, assuming no other forces. The final speed of an object in free fall will continue to increase until it reaches terminal velocity or hits the ground. Influence of gravity. Gravity plays a crucial role in free fall. It is the force that pulls the object toward the air center. Near the surface of the Earth, the acceleration due to gravity is approximately 9.0 meters per second squared. This acceleration causes the object to increase its velocity over time. Characteristics. A constant acceleration through fall, the object experiences a constant acceleration due to the gravity. Parabolic shock. This means that the velocity of the object refers to the same amount of area that follows a curved trajectory known as a parabola. per when it's projected into the air. The object typically experiences as if free fall the mass of the object and vertical motion effect resulting in acceleration path. Initial velocity. The initial velocity of a parabolic should refers to the speed and direction at which the object is launched. It consists of two components, horizontal velocity and vertical velocity. The horizontal velocity determines how far the object will travel horizontally, while the vertical velocity determines how high the object will rise before coming back down. Influence of gravity. Final speed. The final speed of a parabolic mathematical expression, specific conditions of pressure for the motion, including the launch angle, free fall, air resistance, described using the height from which equation of motion, assuming the final speed is typically lower than the initial speed due to the influence of gravity and air resistance. Influence of gravity. Gravity plays a significant role in the motion of the parabolic shock, where h is the height of distance of the object experienced at g is the acceleration throughout its flight. G which affects both taken typically and horizontal components. This equation allows us to calculate gravity cause the object to fly an object during free fall greater than a straight given the time elapsed. Characteristics. Other equation of motion can be used to determine the final symmetry in its trajectory. Or other parameters if the object reach a certain height during the specific information about it will reach the same height to reach the same that in real world scenarios to reach the highest point is resistant time taken to the motion to the same height in free range. The range of parabolic shock refers to the horizontal distance covered by the laser from its launch point to the point where it lands. The range depends on the initial velocity, launch angle, and the acceleration due to gravity. The maximum range is achieved when the launch angle is 45 degrees. Maximum height. The maximum height achieved in a parabolic shock depends on the initial velocity, launch angle, and the acceleration to gravity. The maximum height is reached when the vertical velocity components become zero. Their time taken to reach the maximum height is half to the horizontal to the total time on flight. Mathematical expression. The motion of an object in a parabolic shock can be described using the equation of motion. The key equation for a parabolic shock are horizontal motion. X equal v0 times x times t. Vertical motion. Y equal v0 times y times t minus 1 over 2 times t squared, where x is the horizontal distance traveled by the object, y is the vertical distance or height of the object, v0x is the initial horizontal velocity, v0y is the initial vertical velocity, g is acceleration to the gravity, t is the time elapsed. These equations can be used to determine various parameters of a parabolic shock, such as the maximum height, range, time of flight, and the object's position at any given time. It's important to note that in real-world scenarios, factors such as air resistance may affect the motion of an object, and more complex mathematical models can be required to accurately describe the trajectory of the parabolic shock. Circular motion. Definition. Circular motion refers to the movement of an object along the curved path with a constant radius. In circular motion, the object continuously changes direction while maintaining a constant distance from a fixed point. Initial velocity. The initial velocity in a circular motion refers to the speed and direction at which the object starts in motion. Along the circular path, the initial velocity can be broken down into two components, tangential velocity and a radial velocity. The tangential velocity is a velocity along the tangent of the circular path, while the radial velocity is the velocity perpendicular to the tangent and directed towards to the center of the circle. Final speed. The final speed in circular motion depends on various factors, such as the initial velocity, radius of the circle, and the duration of motion. If no external force acts on the object, the final speed remains constant throughout the circular path. Centrifugal force. Centrifugal force is an apparent offset force that appears to act on an object moving in circular path. It is a reaction force experienced by the object as a result of the centripetal force. Centrifugal force acts outward, away from the center of the circle, and is often described as an outward force experienced by the object with the inertia. However, it is important to note that centrifugal force is not a real force, but rather a result of the object's tendency to move in a straight line due to inertia. Centripetal force. Centripetal force is a real force that acts on an object moving in a circular path, directed toward the center of the circle. It is responsible to continuously changing the direction of motion of the object and keep it in circular path. In uniform circular motion, the centripetal force is provided by various factors, such as tension in a string, gravitational attraction, or friction. Characteristics: a constant speed is an uniform circular motion. The speed of the object remains constant throughout the circular path, while the direction continually changes. This is because the centripetal force continuously accelerates the object towards the center, maintaining a balanced relationship between the speed and radius. Acceleration. Although the speed remains constant, an object moving in a circular path experiences acceleration. This acceleration is known as centripetal acceleration and is directed toward the center of the circle. The magnitude of centripetal acceleration can be calculated using the equation A equals b squared over r, where b is the velocity and r is the radius of the circular path. Period and frequency. Circular motion can be described in terms of its periods and frequency. The period is the time taken by the object to complete one full revolution around the circle, while the frequency is the number of revolutions per unit time. The relationship between period t and frequency f is given by f equals 1 over t. Mathematical expression. The mathematical expression for the motion of an object circular motion involves the concept of angular velocity and centripetal acceleration. The key equation for uniform circular motion is v equals w times r, where v is the linear velocity of the object, w or omega is the angular velocity, which represents the range of change of angle with respect to the time. R is the radius of the circular path made. This equation relates the linear velocity of an object to its angular velocity and radius. It can be used to calculate the linear velocity or angular velocity given by other two variables. Additionally, the other equation can be derived using concepts such as centripetal acceleration and centripetal force to further describe the motion of objects in circular paths.